It was right.
Yeah. So what's the change?
Okay. For the C, I still want intercept, so I got 2.
So that's your C value.
And then for A, it's each one be multiplied by 3.
Yeah.
So I got f of x equals 2 parentheses 3 to the power of x.
Equals 2, and you said what, 3 to the power of x?
Yes.
That's it. This thing is right faster. Where'd that F go? Oh, never mind. Questions about this one? So this is knowing how to get the C, knowing how to get the A. So the A is the change. It's the multiply by 3. The C is always going to be your intercept. So what about the second one?
The B?
Did we do B? Which ones did we do?
But because I did all of them and
Did 1A, 1B. I mean, these should take you like, hopefully you get something like this on your test. I hope you rejoice a little bit, maybe. Because it should take like a second to figure out what C is, what is A. So I think we're having things. So if I want to know what my A is, it should be the half that we're having.
yeah,
A half.
this is 8.
And my C is what number?
8.
8. There we go.
Yeah, 8
Half to the X.
Yeah.
Okay. Y'all are awfully quiet. A lot of y'all are. I hope you understand. You got a test tomorrow over it. I don't know what else to do. If y'all got questions, now's the time. Okay. Clear those. Let me take off annotations on this thing and just scroll on here. Be easier. So what about 2? What's my C there?
Your C would be 4.
Be the Y intercept.
Right.
And
So
the A is 1.
if I fill that in, I get something like what? F of x equals 4a to the x. Then what should I do?
And then we need to find A. We need to find A here. And our A is 1/4.
How do we get that? What are we plugging in?
Because I take 2 points in the table and then I uploaded them to find A.
Okay, so what point did you use? You just need 1 point.
I used wherever in the graph, like I will take the positive 1. Okay, -1, 2.
Did you do 1, 2, -1, 2? Or
Yeah,
any
-1.
-2, 1, I think is another one.
Yes, this one too.
I think I'm probably gonna plug this one in just because it's smaller. We plug into the X and it makes it easier. If I plug in -1 and 2, that tells me my F of X is equal to 2. I have a 4 here and I have like an A to the -1. There are a few different ways to do this at this point. But A to the -1 is like I'm doing what?
Flipping it, right?
Yeah, I'm basically dividing by A to the first power. It's like 1/A. I do 4 times 1/A, I get 4/A. If I do that, I think most of you might be able to see it there. If not, if I do something like that, would that be easier to solve?
Yes.
I'd do what? Butterflies, right? 2A is equal to 4, right? 2A equals 4. Or A is equal to?
Yes, and then
It would be
2, right? Okay.
it should, yeah, 4 times 2 of X. It's not 1/4, sorry, because it's my first scratch paper.
And this is 2 to the X is what I'm thinking.
Yes.
Is that right? Is the y doubling each time?
Um,
Does it
Yeah.
look
yes,
second maybe? We're going
yes.
from 1 to 2 to 4. That
Mhm.
would be doubling.
I had wrote the chart. I had made a chart for it if I could physically see it.
Yeah, you got to make a chart for these things. Make a chart. I mean, it's the same information. They're just presenting it differently, right? You're still getting points. The graph just gives you more points in between that you really don't need. All right. So what else did I tell you? Where did that chat go? 3, C, and D. Did anybody get these? Or am I going too quick?
I started on 3C, but I'm not sure if I was doing it right, but I started on it.
Okay.
The first thing is I had raised both sides by log 5. If I could get the 5 off first, right?
So if I'm looking at this, it's got an exponent, but where is that exponent at?
You said
What's the base of that exponent? I guess is a better question.
2.
five, right?
On C.
E.
Yeah, that's like if there's anything on 5, it would be like a 1, right?
Yeah.
So in between 5 and that E, what's the operation there? Oops.
Is it add, right? No, between 5 and E. Yeah.
Mhm. If you don't see anything there and you just have a letter and a letter or a letter and a number, what's the operation?
It'd be add. Multiplication.
Yeah. If I got something like 5x, that means 5 times x, right?
Yeah.
This is multiplication. So how do I get rid of this? I want to get just the E by itself.
Would I divide?
Divided by 5.
So if I divide each side by 5, I get x plus 1 on this side. E to the x plus 1, I get 20 on this side. 100 divided by 5.
Yes, 20.
And then,
And then you plug your natural, your AN.
yeah, so you do the natural log. So I'm doing
Okay.
natural log of both sides. Natural log of this thing. Natural log of this thing.
Mhm. Then it's going to be IN is 1 is x plus 1 equals to IN 20.
Oh, so I get ln and e, and what I hope you notice at this point is like these are inverse operations. So whatever e is doing, ln is undoing it, right?
Mhm.
So I end up getting just the thing that's the exponent on my e. I end up getting something like what, ln of 20 on this side?
Yes.
And I think there's one more step to solve for x. What do I have to do?
Yeah. Subtract by minus 1.
You got to subtract 1.
Yeah,
What?
by 1.
Question? Someone said something. I heard a voice that wasn't mine. Okay. All right. Does this seem like something that's doable?
Yes, because I end up getting x equals ln 20 minus 1.
That's it. The LNs and the E's are new here, but it's the same strategy anytime we get something we don't know what it is, or anything that's new or weird, we get that thing by itself. We're just play math bully, basically, right? Get him alone by himself. When we get the E alone and by itself, oh, shoot. That's not what I want to do. Okay, hit the wrong button. Let me use the eraser. Once we get, no, can't do it now. Once we get the E by itself, so that would be like this step right here without the ln. Once we get the E by itself, we can undo the E. We can undo the exponential, the E exponential with a natural log. So this is a step where we actually start using like kind of new stuff. And I said it earlier when I was talking to someone, like if you have to, right? If you have to look at these things, let me do different color maybe. Like you can look at this whole thing as just like a variable. So like just say that's an X with an extra line drawn apparently. So you can look at these things sort of like it's its own variable. Ooh, I'm drawing lines and not doing the pin is what's happening. That would be better. So you can look at that thing like it's its own variable. And if we had 5 times X equals 100, I almost guarantee you everybody would tell me what to do. No problems. I would hope. Questions about this? We did C. What was what? C. The other one I'm going to do was E. Let's clear this. Apparently, I got to take my annotations from here. Can I clear all my drawings? There we go. And D was the other one.
The first thing you do is subtract 2 from both sides.
So we'd get a minus E to the X. There's like some lag happening today that I don't usually get. So if we subtract 2 from each side, I think the one thing you have to be careful is that there's a negative on the E to the X here, right?
Right.
And so if I subtract 2 from both sides, I get a negative E to the X equals -1. And the next step I'm going to do, I don't want that negative, so how do I get rid of it?
Divide.
Yeah, divide by a negative, multiply by a negative, whatever you want to say, right? But I get E to the X is equal to
1.
1. You might be able to do this one without doing logs. This is a property.
Before we move to the next step, my question is, to get rid of the negative, we have to divide by 1, right?
By -1, yep.
By -1.
Yeah, so we're basically flipping the signs. And so how to get rid of the E?
Not the natural.
By ln, right?
Yeah, doing the natural log. Natural log. So the left side is giving me ln of E. We talked about that. It should just be that the X that's up there.
Mhm.
And I'm getting ln of 1, which is okay. But this one I can actually evaluate, right?
Yeah.
ln of 1 is what? That's one of those properties we had.
By calculators? Do it,
I heard like 3 different things at the same time. I'm not sure what it was.
Is it 0?
It is 0, right? This is going backwards, right? E to the something is 1, right? Is what we had. E to the something is 1. Not 0. Erase. E to the something is 1. What is that something? Anything to anything to the 0 is 1. Yep.
Yeah.
So you got to think backwards of what? Exponents. If we're getting 1 as our solution, what was the exponent? The exponent was 0.
In this case, X equals to 0. Yes.
Yep. And if we wanted to, I guess we could really go check that. 2 to the E to the 0, is that equal to 1? You go plug it back in if you really want. Check your solutions.
Sometimes we think hard, in the same time the solution is easy.
Yeah, it's weird when everything cleans up and you get like an X minus 2 out of there or something. I was on the previous test. There's like 10 different things you're factoring and then everything cleaned up. All right, and so that was 3. I don't know why they put 3 before they put 4, because a lot of those things in 3, I think we're going to do basically in 4. These are properties. So I said what? B, D, and F. I guess those look all right.
Do we still in question number 3?
3, C, and D. We did 3, C, and D already, right?
Okay, yes, we did.
Shoot, wrong one. And so now we were doing those three, B, D, and F in number 4.
Okay.
So if I get like log, if I don't see a base on the log, what is the base on the log?
It's 10.
It's 10. So if I see log and I see 1 over 10 to the 9, ooh, excuse me, 999. I guess I could rewrite that if you really want me to.
Yeah, it crosses it out. Right?
So if I were to write it to just the base 10, not 1 over.
Like 10 of the power of 999.
Negative.
What would I put on that 999 to fix it?
Negative.
Negative, right? And if I'm gonna flip it,
Yes.
I mean, there's multiple ways you could do it. You might see it without doing this step. What if this is 10 to the minus 999 and I'm doing log base 10? What is this thing equal to?
Would it be
Minus 999.
1 over 999, right?
No,
It's this thing right up in here.
because log 1, it's going to be log 1 minus 999. And log 1 is 0, and the result is minus 999.
Yeah, so this is the thing I have circled in red here, right? Log base 10 and 10 to the something. Those are the inverses, right?
Do they cancel each other?
Yeah, so those simplify out. Whatever that 10 to the is doing, that log is going to come out and undo it. And so this should give me minus 999. So basically, if you have 1 over something, it's a negative exponent, right? If we had log base 10 to the 999, I guess this is the other thing, right? If it was positive 999 and we weren't doing 1 over, it would just be the positive 999, right? Okay. Questions about this one? We had a few like this. Maybe they weren't 999, they were like 3 or 4 or something, right? But same concept. Putting a larger number on there really doesn't make this a whole lot harder. It just makes the number larger. The operation's still the same. So D and F were the other ones. D might be a little bit challenging in its own right. This is 3, log base 3. There are a few ways to do it, probably. But if I want to rewrite 27 as something that's base 3, can I do that?
Yes, 3 of 3 to the 3 power of 3.
That's 3 to the power of 3. So what I'm saying is 3 to the third is 27, right? I'm just using this fact right here. Rewrite things as base 3. So if you have a log and a base, try to rewrite that number inside your log as something that is a base, that is the same base as that log. And so now if I'm looking along here, is it 3, 3, or 3? Those two things, right? They didn't give us a whole lot of numbers to choose from here, so I guess you could probably guess and pick. But those two things I just circled in green, those are the inverse operations, right? So if I do 3 to the something and I do a log base 3, those things are going to undo themselves, right? And I'm going to end up with, that's the 3 that we're bringing down, just so we're clear. Questions on this one? Okay. And then the last one, ln of e to the 12.
Please tell me 12.
All right. I hope so.
Okay, because I'm like, please tell me it's 12. Okay.
Yeah. So the ln and the e are inverse operations, and we're going to end up having like this thing that's up here.
It's 12. 12 in of e equals to 12.
Yep. That should be it.
Yeah, it's the easiest one. Just put it by can't.
What about e?
Yes, E is the same thing, log 1 over A. It's log, like the definition, the roles, log 1 minus log A, which is minus log A.
This is -1 because it's on bottom, right?
And then for C, would it be the negative 4.72?
Yep, that's it.
Yep.
Yep. All right, where are we at in time? All right. 6B. Use a calculator. I don't want to waste time on that. They got the solutions in the back. If you're having problems getting those numbers, let me know. We can come work through them. But 6B, I want to do this. Solve the equation, give an exact symbolic or decimal approximation. We did some where we solved what exponentials. I think now we're solving logs.
Yeah.
Same sort of strategy, except like one step's different, right? Instead of undoing exponentials, we're going to undo logs with an exponential.
Here, it's 6B, right?
Yeah, so
We have like 2 plus 3. We move 2 to the other side. It's going to be 3 log x plus 1 equals to no,
so
4 minus 2. It's 2. It's 2.
I said it earlier, but like if that's what's messing you up, look at your ln like it's a big variable x, right? How do I get that by itself?
Okay. It's n of x plus 1 equals to 2 over 3. And like we need to upload the natural, no, the E.
So if I have something like 2 plus 3x equals 4, what's the first step I'm going to take to solve for x?
You would subtract the 2, right?
I would subtract the 2 first.
Right.
And if I do that, I get something that looks like maybe like 3. I'll just keep it x for now equals 4. And if I solve for x equals 2, sorry. I wrote the thing down, didn't do it. So what's the next step?
Get rid of the 3,
Yeah, so how do I move the 3?
divide.
Divide by 3.
Yeah.
So I got this big thing right here. This big thing is really ln of x plus 1.
Equals to 2 over 3. Then to go out of the in, we put the e in the other side as x plus 1 equals to e power 2 over 3.
So we exponentiate this thing with a base of e. So
Yes, base of
fancy
e.
words. But basically, we're going to let these be our exponents with something that is a base e.
The base of 2 over 3.
And on the left, what do we get if we do that?
X plus 1.
Yeah, that was the whole goal, was to get rid of that ln by exponentiating things. So we get x plus 1 equals
X equals to e power 2 over 3.
and then we're like one step away.
Like move your plus 1 to the other side, going to be minus 1. X equals to e 2 over 2, 3 minus 1, like the power.
Yep. So x equals e to the 2/3 minus 1. That's it.
Yes.
Questions about this thing?
So the 2/3 need to be an exponent, right?
Yes, this should be the exponent on that e. I know I was doing x, but this really should be x plus 1, right? Questions about this thing? The strategy is still the same. The new thing that's weird, the e or the ln, you treat that just sort of like it's a variable on its own. You try to get that thing by itself. If we have a log, we're going to have to exponentiate things. If we have an exponent, we're going to have to log things. we get rid of the exponent or the log, and then we're still just solving things like a sort of first order linear equation, right?
Yeah.
Okay. What was it, 6B? That was the one we just did.
Oh,
Right.
we did.
These are almost exactly the same as those other ones, right? We're converting this to base 4. This is just a -7. That's the identity property. Log base 3 of 10. You're going to change a base, right? I don't think there's an easy way to do that one.
Which one for 7?
For 7C, yeah. Log 10 over log 3, whatever the heck that is. I think you have to use a calculator for that if you want an approximation. Find the domain.
Can we do one of those?
Okay, so log base 6 of 2x plus 2x minus 1. What about this one? What does my exponential function look like? These were exponential functions. That was exponential growth, right?
Excuse me, which number, teacher, please?
Exponential decay, 8b.
8B.
If they give you something like this, I hope you celebrate a little bit.
Mhm.
Maybe.
Maybe.
If we think about exponential, what can our x not be in an exponential?
Mhm.
0,
Maybe.
right?
The egg,
We can get a 0 here, right? We get an intercept.
minus 1.
Maybe it's a weird question. Because what is the domain?
Infinity?
Yeah, it's from infinity to infinity. There's nothing that we can't plug in. There's no restriction on exponentials.
Oh, okay.
Look, for the 8, excuse me, teacher, you are, it's not 8A, it's 8B.
8b, yeah. 8b should
Yes,
be
8B is minus infinity plus infinity, yes, but if it's the 8A, it's the 1/2 until infinity, plus infinity.
yeah. So if we think about exponentials, what can they not be? They cannot be 0, but they can be anything greater, right?
Yes.
Fractions are going to give us negative numbers. And then this is going to be like the 1 right here. It's going to go through at 1. And then anything greater than 1 is going to give us something larger, a positive number, right? Okay, so this says that the thing inside the log, so if I have like log of x, the x has to be greater than 0.
Mm.
So now if I do log base, the base doesn't really matter. It's going to
Yes,
determine the steepness of the graph, right? But it's still going to go through at 1. Things that are fractions are still going to be negative. Things greater than 1 are still going to be positive. It's still going to have the same basic properties. And so if I'm looking at this, what does this tell me about the thing inside the log?
For the 2x minus 1 is greater or equals to 0.
Yeah, so 2x minus 1 is greater than, you say, or equals to?
To 0, yes.
Can it equal to 0?
No, we can't. No, just greater.
This is greater than, yep. And so
just
2x
greater.
minus 1 is greater than 0. So if I want to solve my domain,
X equal
basically
greater than 1
solving-
over.
yeah, I'm basically solving this thing. So 2x minus 1 is greater than 0. I'm going to what? Move the 1 over.
2.
And I'm going to divide by 2. So I think this is going to give me something like x has to be greater than a half.
Mhm. And then your domain is 1/2 plus infinity.
So if you want to do it, yeah, in interval notation, it'd be a half with a soft bracket off to infinity.
Yeah. This bracket, it confused me each time. Yes, it's a bracket.
Okay.
Because it's greater, it's not greater.
Yeah, the square root you can do equals, right? But the log you can't.
Yeah.
I think that's the difference.
Yeah. Okay.
Okay. Sketch a graph of the function. I don't want to spend time sketching a graph. You're going to do a t-chart or something like that to get a few points. Right as a single log. I want to do a few of these. I want to do a few of these. That's all right. Rather do 11. 10 and 11, I think is what I want to focus on now. Let's do, I don't know, 10A and D. Do 11. There's only 2 on 11. So just do all of them, A and B. And then I want to do some word problems.
Yes, there's more. Those word problems are toughest one.
Just in 8,000 is compounding quarterly. 14 looks like a pretty good one. Compounding quarterly, let's do 14. And then one that says continuous.
I think 19 to teacher, please, if we can do 19.
All right. How much money you have after 2 years? How much time does it take to grow? We need one of those too. This is continuous compounding, so let's do 16. It looks like that's asking how much time. Alexa, stop. I need to turn off my voice recognition, apparently. It keeps beeping at me. How much do you need to invest? Oh, it's asking for, no, I want one to ask for time. Is there not one like that on there? That'd be 15. Let's do those 3, 15, 16, and then we'll work through 19. So those are the ones I want to focus on next. And then after we get through with those, we're gonna have to go jump to the other one. So hopefully you're also looking at this other one. This is the one that is cumulative. So I hope you look through these problems as well. Come and ask me. I think there's only 13 on this one though. Huh? So be prepared. If you have any questions on any of this, let me know. Now's the time to sort of ask those things. I'm gonna bring out breakout rooms so we got enough time. All right. 1, 2, 3, 4, 5 problems. I'm gonna do it. 6 problems. I don't know how to count. 10. How do we do 10? So like 10A. This is what, condensing, right? So I think we're gonna do a few condensing and then we'll do a few expanding. What's the first thing you did there?
Move the 2.
Yeah, move the 2. So now we're doing ln of, I believe, 3 squared. I hope that's what you did.
Yeah.
Plus what, ln of 4 minus ln of 6.
Yeah. And then you group the first 2. I did ln. I'm not sure this is correct, but I did ln 3 squared times 4.
Yeah, 3 squared. I'm gonna like just make that a 9, all right?
Yeah.
We're doing 9 times 4 inside the ln basically. Minus ln of 6.
And it's gonna give you ln parentheses 36 minus ln 6. And we're gonna divide ln to parentheses 36 over 6. And ln 6 is the final.
Yeah, I'm running out of room here, but it should end up just getting ln of 6. So we're starting this off and we're working this sort of backwards of what we did when we expanded. I think we started expanding first and then we started condensing. But when we were expanding, the last thing we did was those exponents. So that exponent rule, if it's out in front of the log, we can bring it up as an exponent inside the log, was the first rule that we used. The next thing is that if we're adding 2 logs, we can combine them as multiplying inside the log. So I get ln of this thing times that thing, right? ln of 3 squared times 4. Or ln of 9 times 4, which is an ln of 36. And I'm still subtracting an ln of 6. Now we're using this property if I'm subtracting 2 logs. It's the same thing as dividing inside the log. So I'm doing 36 divided by 6 inside my log, so I should be getting just an ln of 6. Questions about this one? Okay. That was what 10A. The other one I said was what 10D. So 10A's got nothing but numbers. 10D, we're throwing in maybe some variables in there. So I'm looking at this one, ln of x minus 1 minus 2 ln of x plus ln of 2x. What's the first thing y'all did here?
Dividing the first part.
You can divide that,
Oh, I
Wait.
moved it to -2.
but yeah, I think you need to move that -2 first. So minus
Yes,
n
yes.
of x. Waiting for someone to say it.
The X
Oh,
one, two,
Minus an x squared.
You got to have an x squared, right? So that 2
Yes.
in front of the ln is going to become an exponent on that x.
Yes.
We're moving that thing inside the log. We're going to move it as an exponent minus ln of x squared and then plus ln of 2x.
Yes. This one is.
So I'm looking at these two.
Mhm.
This is going to give me ln of what?
N of x minus 1 over x squared.
I can combine these two things with it's subtraction on the
Divide it.
outside, it's division on the inside. That's what I was trying to say. X minus 1 over
X squared.
x squared. And I still have that plus ln of 2x thing happening here.
And then we can do this one too. It's going to be I and x, like the addition is going to be multiplication.
X minus 1, and I got an x squared on bottom. And you're telling me this addition is going to become multiplication. So I'm multiplying by what?
By 2x.
Okay. So we have it combined to one log. We just got to do a little bit of cleaning inside that log yet.
Which is 2x minus 2. No, 2x squared minus 2. Yes. Okay, because I cleaned the whole thing before.
Yeah, I don't know if I would distribute it. I might keep it factored, but I would make sure that I put that 2x on the top probably.
Yes, the 2x is going to be in the top, like like 2x. And okay, x minus 1 times 2x over x squared. We can across 1x, and it's going to 2x minus 2 over x.
Are you distributing?
Yes, I distribute
Yeah,
it.
that's
and
fine. So you don't have to distribute it. I would probably keep this factored personally. Just because if I'm doing other things with it, I want to see if those factors simplify. If you distribute it, I'd give you full credit too.
because I distributed and I across it, and my final results is n times 2x minus 2 over x. The whole thing, like
It should be
between
2x. It should be 2x squared minus 2x.
because I across 1x.
Oh, one of the x's simplifies out, doesn't it?
Yes, because we have
Yeah, woo.
square in the bottom.
I'm waking up this morning still, apparently. One of these x's should simplify out with one of those x's.
Yes,
That's correct. Yeah.
thank you.
what would be the answer?
That's it. So one of these x's will simplify out. So it should be x minus 1 times 2 over x.
Yes,
Or you could do 2x minus 2 over x would be fine as well.
that's what I did.
Minus 1 point on my test. That's what I get. Yeah, so make sure you're fully simplified and do as I say, not as I do. Questions about this one? Okay, that was 10D, is that what we did?
Yes, we
Yeah.
did ND.
And the next one I said was 11A and B. So these are condensing to one log. So if we have something out in front of the log, we can exponentiate it, right, inside the log. If we're adding two logs, we can multiply the logs. If we're subtracting, if we're subtracting a log, then it's dividing. Now we want to expand these things. So ln of x minus 1 over xy.
Subtract it.
Would it be ln parentheses x minus 1 minus x and y? I mean, L and y?
Yeah, so we have ln. The first thing we're doing is working on that division. So that division becomes subtraction on the outside. We get two logs. One is ln of x minus 1. We're subtracting the log of ln of xy.
Right.
Oh, okay. I see what I did wrong.
That's what you told me.
Yeah.
I'm pretty sure that's what you said out loud.
Okay. Boom, boom. All right.
All right. Are we done?
No,
You gotta do 11b.
no, because here we have a n of x of y is the multiplication is going to be the addition.
Yeah, so this is addition. So this is like an ln of what?
X plus in of y.
Yeah, so natural log of x plus natural log of y.
Yes, sorry,
Okay.
I give the half answer. Sorry.
And we had one like this. I remember this. We had one almost exactly like this in homework, right?
Okay, I think yes.
What do I have to do here?
It's
It's one of those things, if you're not careful, you might miss it, right?
Yes, like the you mean the negative?
Mhm.
Okay, then it's going to be in x minus 1 minus parentheses in plus in x plus in z.
Yeah, so you want to either like put,
It's
Parent-
y.
you either want to put parentheses around this thing, or you want to just like go ahead and maybe distribute that negative, but one way or another, you want to make sure that negative gets distributed to both of those logs, right?
Yeah.
You want to make sure that that ln of y ends up becoming a minus ln of y. And if you're not careful, I guess that's where you'd mess up. So there's some distribution. That x and that y were both on bottom. They should both end up having a negative in front of them. Pretty much if you have something in the denominator, it should end up with a negative in front of the log. So ln of x minus 1 minus ln of x minus ln of y.
Okay.
Questions about this? It's the same properties, just the other direction, right? If I'm subtracting on the outside, I'm dividing on the inside. Wait. No, if I'm dividing on the inside, I'm subtracting on the outside. That's the direction we're going now. And so I subtract the numerator from the denominator, and I still see that this denominator has things that I can separate that are being multiplied on the inside. So this is addition, but I'm subtracting the entirety of that second term. All right. So that was 11A. Questions before I clear it? All right. 11B.
It's the same thing.
Similar, yeah. So I get log 3 of what?
Log 3 of x, y. This one is the denominator is going to be the addition and the minus.
Yes, I'll do it maybe like one step at a time.
Okay, it's going to be log base of 3x times y plus 1 minus log z of 4.
So I'm more working on that division first on the inside. So I do log of the numerator minus log of the denominator. And then I think you were telling me this next. I can still split this thing up a little bit. So how do I split that numerator up?
The addition, the multiplication.
Mhm.
Oh, no, so
Multiplication
multiplication is-
becomes addition. Yeah, that's it.
addition.
Well, let's see. All right, so that's log base 3 of x, and we also have multiplication becomes addition. And this is log base 3 of y plus 1. And we are what? Subtracting log base 3. What can I do with that z to the 4th?
4. Put
Do the
4 in
4.
and the times back.
Yeah, I can bring the 4 down in front. So I get log base 3 of x plus log base 3 of what? Y plus 1 minus 4 log of z. Questions about this
Oh.
one?
The bottom green part, it all goes together, right?
Yeah, this should be one thing. I got it on multiple lines because I ain't got enough room, basically, right? So log base 3 of x plus log base 3 of y plus 1 minus 4 log of z. What about this? Can I separate this any further?
No.
That y plus 1. I think this is the next thing people try to do, and it doesn't work too well. That's done, right? If it's addition on the outside, that's multiplication on the inside, but that's addition on the inside. Okay. That was what, 11b? What was the next one? 14? All right, so the formulas for these things should be provided for you on the test. I'm not expecting you to memorize like formulas. Amount equals principal. 1 plus r over n to the nt, I think is one of them. And the other one, you probably got this one memorized because it's just a shampoo. A equals PERT. Those are the two formulas we'll probably need for this. So if you invest 8,000 in a money market account at an annual interest rate of 8.5% compounded quarterly, how much money we have in the end of the account in 10 years? So which one of those formulas are we going to use?
I think it's the PE of R of T.
Well, how do we know which formula to use?
Because we have the principal is 8,000. We have the rate, which is 8.5%, and we have the time after 10%, after 10 years.
Well, what's the difference between this first one and this one? What's the word I'm looking for to use that second one?
Maybe the compound.
Continuous, right?
That second one we should use for continuous.
Okay.
Hey, come sit down. Oregon. All right.
What's the other one used for?
Anything that doesn't say continuous, any sort of compounding that's not continuous. So what does this say about being compounded?
Excuse me, teacher, you mean each time we see the word continuously, we are going to use the second formula?
The PERT, yeah.
Thank you.
The PERT formula. It continuously makes your hair shiny and silky smooth, right? So this says what? The word I'm focusing on is what?
Quarterly.
Quarterly, right? What does quarterly mean?
4 times at the year.
And which variable is that?
1 over.
And
That's my n variable. So what this is telling me when I see quarterly is that n is equal to 4. Everything else is going to be almost the same, right? Except for the E or the N, basically. Those all the other variables are there in both the formulas. So if you see continuous, we're using the second one. We don't see continuous. I know my N is 4 because it says quarterly. So if you invest 8,000 in a money market account, how much money will you have in the account at the end of 10 years? What variable are they asking for?
A.
Yeah, the money at the end of the 10 years is the accumulated amount or the A. What's my principal then?
8,000.
What is 1 is 1. R is
0.085.
0.085. We're moving it 2 decimal places. We're dividing by N, which I already said was
4.
4. And NT is going to be what? 4 times
10.
times the 10 years. Questions about this thing? All right, so how am I going to do this? I got 8,000. I have 1 plus 0.085 in a calculator is probably the correct one. The correct response, right? I'm not doing that by hand. This is 1.02125. And I'm going to raise that to the 4 times 10. I'm off the screen now. I should say 40 up in here. I want to raise.
Excuse me, teacher. Here we have the n equals to the quarter. It's like 1/4. It's like 4th, 1/4. It's not 4.
N is the number of times per year you get compounded. So if we're doing it quarterly, it's going to be the number 4. If we're doing it semi-annually, it'll be 2. If we're doing it monthly, it's going to be 12. It's however many times per year.
Okay.
And so we get, that's giving me something like 2.318. When I do to the 40th, I'm getting somewhere around 2.318 something. And the last thing I'm doing is what? Multiplying by 8,000.
Are you rounding?
I am definitely rounding on that thing. So I'm not going to round on my when I do it in my calculator though. I'm just going to grab what my calculator is giving me and use it. So if you're getting something like 1855, 1 point, I believe 23 is the solution we're looking for. Is that what they say in the back? They may check this. Yeah, that's it. They do it to the nearest dollar, I think is where they're doing it. Yeah. If you didn't get that, maybe don't round as much on the previous stuff, but you should be able to get pretty close. Questions about this one? Okay. That was what, 14? So 14 is what I would like probably say it's like the straightforward thing, right? They're giving us the formula. They're giving us the variables to plug into the formula, and we don't have to do any like back solving to do 14. 15. Which formula am I using? Am I using the PERT formula or the other thing?
Or the first, no, the other thing.
Yeah, compounded annually is the keyword, right? So if I say it's compounded annually, that means it's compounded how many times per year?
Would it be 12?
If you're doing it annually, how many times is that per year? It's
Once
kind
a
of-
year.
It's,
Yeah,
it's
once
kind of a
a
silly question. Yeah, it's once per year. Maybe it's a weird question, but there it is. P1 plus R over N to the NT is what I want to do. That's my formula. How much time does it take to grow from 1,500 to 5,000 at an annual interest rate of 7.25 compounded annually? So do they give me accumulated amount?
Yeah.
What is that?
It's, is it 15,000?
Principal is what you start out at. Accumulated
Oh,
amount.
it's the
how much
five.
it takes to-
It's the 5,000.
It's the 5,000. So this is my 5,000 is my accumulated amount. My principal was
Your principal is 1,500.
the 1,500. And I want to do 1 plus my R is what here?
0.0725.
The interest rate 0.725. So I'm gonna do my 5 there. My N is 1,
1.
and we're doing 1 times how many years?
We don't know the years yet.
We don't know the years, so I guess keep that as your variable. All right, this is my setup. So this is half the battle here, maybe. I have this thing. How do I want to solve this?
By dividing the first part.
Do what's in parentheses first, right?
Yeah, I mean, there's a few different ways you might want to clean this up. If you want to do things in the parentheses first, you can do that. So if we do that, 1.0725 divided by 1 is just going to be 0.0725. So what this in the parentheses ends up becoming is what? 1.0725 to the t. 1 times t is just t. So there's a like dividing by 1 and then multiplying by 1 that we could probably just like kind of throw out, just the identity sort of thing. Simplify it out a little bit. So we have something like this. Hopefully this looks like something we were doing already earlier. A little bit.
Like 5,000 over 1,
Yeah, so
1,500 equals to
this is the weird exponential thing I want to get by itself. So I think you're telling me the right thing, right? We're doing 5,000 over
1,500 something.
the 1,500, and that's going to give me 1.075 to the t,
Yes, equals to
which is what, 5,000 over 1,500. That should be 3 1/3, 3.333. All right, so how do I get rid of this 1.075 to the t?
I think we need to check the natural log.
Yeah, you can do the natural log and bring down the t.
Yeah. Or the exponent. How do we need? Do we can do the exponent e over the? I don't know.
So we're doing a natural log of both sides.
Mhm.
And why'd you do the natural log? What can we do with that t then?
Put it in the front.
Do it what?
Like it comes to the front.
It comes to the front. Yeah, we bring down that exponent of a t to the front. This is the way a lot of people do it. I'm a weirdo, probably. but this is T ln of 1.075. I don't have room here anymore. And so if we want to solve for T, what do we have to do? I think we're dividing a log by a log, right?
Yes, that's just because I can't see. Just put your as an x like t itself and dividing the other parts. other
Wait,
side.
why are we dividing?
We have
Because-
T times this thing times a log of 1.075. And so we want to get T by itself. So at this step, I would probably not do natural logs. I would probably do, it's kind of a weird thing, but I can do a log base 1.075 if I have a calculator. I can calculate that just as easy as anything else. I'd probably just say log of 1.075 each side. So I would end up getting something like log of what, 3.33 base 1.7075. And then I'd have to change a base formula. So I'd end up with basically with the same thing. So if I do ln of 3.3333 with a bunch of threes, I do ln of 1.075. I should be getting something like 16.647, 16.65, I think is what I'm getting when I crunch that. And so what is that telling me?
It's the time.
It's the time. So it's telling me it's probably going to take me 16 and what, like 2/3 of a year, probably somewhere in that ballpark.
Month.
If you want to know how long it's going to take you to save that amount and you wanted to be nice and like give them kind of the conservative, I would probably tell them it's going to be 17 years. It's going to take you about 17 years is what I'd probably tell them. Because if you tell them 16 years and they don't have that amount, they're probably going to be mad. Just using the context of the problem a little bit, maybe. I would probably say 17 years. I don't know what they say in the back. I guess I could look. 17.2 years. I don't know how they're getting the 0.2. Maybe I did some rounding or something that didn't like.
But the point here, teacher, in these word problems, it's like we need to find the good for the formula and how we do the last steps as log. Right?
Yeah, so this one we're solving for the exponent, right? So when we see the formula, we see something like 5,000. This was my original formula, 1,500. I get 1 plus 0.075 over 1 times t, right?
Mhm.
1 times t. And so what we end up having is we have a something with an exponent, basically. We have the variable in our exponent, and we need to get the variable down out of our exponent. So how do we do that? We take a log of both sides. So what I would probably do is take the log base of 1.075.
Like it's the easiest way to go out of the.
Yeah, and the thing you're doing is correct, and a lot of professors do it that way as well. I've seen a lot of professors work it the way you're doing it. We can take any base log of both sides, and we can bring that t down in front. That's also a correct way.
Okay.
This is just my way because I'm lazy, basically. If I have a calculator, I'm going to use it to my advantage. That should be 5,000. So let's do it maybe exact. If I do log base of what, 500 instead of rounding things over 1,500, does that give me the thing they're getting in the back? Log of 1.075. Yeah, I don't know how they're getting 17 point whatever the
I
heck.
think here, teacher, the point is to find use the good formula and to find the steps. I think the results depend on the. I don't know.
I don't know how they're getting what they're getting in the back for this, to be honest.
Okay.
Because in the back they're saying it's like 17.2 years. They must be rounding things way off or something weird. Because I keep getting 16.65. And
Okay, cause
It's
this,
near to 17.
I was over here lost, like, wait, huh?
15, yeah, I don't know where they're getting that from. Doesn't seem right. Unless I wrote something down wrong. That's right though. Okay. 0.0725. Yeah, that's it. Oh, I forgot a 2. That's how they're getting it. I forgot my 2 and my 725. Yeah, it should give you 17.2 years. They're right. So don't drop numbers. I know it's a test, but don't do that to yourself. It should be around 17.2 years. So if someone asks you, you would probably tell them it's a little over 17 years. Is probably what you would tell them, right? Questions about this one? All right. All right, we got to finish this one off and then we got to get to the other stuff sometime today. 19 was the other one, I believe. 16, 19. Oh, this one continuously. So which formula am I going to use for this one?
The perk.
That's the PERT formula.
Perfect.
4,000, I believe. No, 4,000 is your A, I believe. Is the accumulated amount. You purchase new energy, same appliance 10 years. The estimated cost is 4,000. How much do you need to invest now for it to be continuously? So I'm just going to do the setup for this one because I want to get to the other stuff. But I believe we're solving for principal. I believe they give us E and they give us R as 0.065. And T is what, 10? So this thing is just giving you a number that you're going to divide by, basically. You're going to throw that in your calculator, divide 4,000 by whatever the heck that gives you. And that should give you your P. The other one, you said what, 19? This gives us a population. T is the number of years, P is the population. What will the population be in 10 years? So what do we do for this one? Ten, what value is that?
Your time.
Yeah, it's the time. So we're plugging that into where?
The T.
The T up there. And then we're just evaluating that. How long will it take the population to reach 1 million? What are we doing there?
We upload the A amount equals to 1 million to
That's-
find.
And this is equal to that formula they give us, right? 1 million is equal to 65,000 e to the 0.07 t.
Mhm.
And then we're gonna have to what, divide, and then we're gonna have to do a natural log. Okay, I want to get to the other thing for a few minutes at least. Are there any questions over anything on this review? Is there anything that's just like dumbfounding you, you don't know how to do? How do we do these? What's the easiest way to do these? Systems of equations. I guess it tells you at the top, doesn't it?
Oh my gosh, teacher, I forget all of them. And then I went back to review and then, yeah.
And it's something like 10000.
100010101.
001.
Yes.
Yeah. What do we call that?
Gaussian Jordan. Gaussian
Matrix.
Jordan.
That, right? Row reduced echelon form. Echelons that diagonal.
Yeah.
Yeah, so that's what we're doing. We're throwing this into matrix 2 minus 1 minus 1. And then what? Minus 1. This is the first line. 1 minus 3, 2, what? 7. And then I have 1x. I have no y's. I have minus 1z. And I have minus 2. So this is my matrix. You can use what? Gauss-Jordan elimination. I'm not going to do that. I'm going to go to my matrix and I'm going to use my calculator to my advantage. So if I get something like what? 2 minus 1, minus 1 and a minus 1, and I get 1 and a minus 3 and a 2 and a 7, and I get 1 and a 0 and a minus 1 and a minus 2, and I go matrix, I go math, I go row reduced echelon form. My calculator is going to spit out something like 1 0 minus 1 minus 2, 0 1 minus 1 minus 3, and then on the bottom it gives me nothing but zeros.
It's dependent.
It's, yeah, it's independent.
No, it's dependent with the.
Depend.
With
Yeah, that's what I meant. Same line, right?
Yeah.
So we have to give an equation of a line, maybe x minus z equals a minus 2 is what this line gives me if I spit it back out from the matrix. Y minus z equals 3 minus 3.
No, teacher, I think you made mistakes in your calculators because I don't know if it's me or you. Which one is? Because I find 1 3 2 1 3 2 7 0 1 1 3 0 0. All the other sets, all of them 0.
Minus 1. X minus 3 2 7, and I have 1 minus 1. I think no, that's what I'm getting out of my calculator.
Because I did them with hand, and I find this result. And 1 3 2 7 0 1 1 3 all 0 0 0 all zeros. 4 zeros in the bottom.
Do you get nothing but zeros on the bottom?
Yes, I get nothing in the bottom, and then I find my z is z and y.
Should be
Y.
Z.
Yes.
So y minus z is a minus 3. So we're doing x, y, z. So x is, I believe, z plus 2. If I move that over.
Mm-hmm.
Y is going to be z minus 3. And then the last thing you should have is z. And there's solutions in the back. What do they say? So what they say? Z minus 2, z minus 3.
Yes, and z.
Oh, this should be a minus 2. I messed up my negative here. There should be a negative there where I didn't put 1.
You missed your minus in the second part. You are going to have y plus z equals to 3. It's not y minus z equals to 3.
Y minus z.
It's
No,
y.
that one should be negative.
If it should be negative, you are going to have your.
Yeah, and we add the z over. So it should be z minus 3. It should be z minus 2.
It should be 3 minus z. For your y equals to 3 minus z.
Yeah, that's what I said. Z minus 2, z minus 3, and z. Is what I'm getting this out.
Sorry.
Yeah.
We should remind everybody about the Zoom requirements for tomorrow
Okay.
before we go, because it's 1:41.
All right. So for your final tomorrow, you are expected to log into class with your phone or some other device we want you logged into Zoom while you're taking the test. Does anybody have questions about what the requirements are?
And that device should be angled so we can see your work area. If you don't do that, you will not get your exam graded, which means your Thursday exam will have to replace tomorrow's, assuming you do Thursday correct. So everybody needs to log into Zoom with a device tomorrow and angle it so that we can see your work area.
Okay. Any questions? I'll take one more question, I guess.
I have to go. Good luck to everybody.
Thank
Bye.
you.
Thank you.
Have a nice day.
And also, I have office hours before class tomorrow, before class the next day. So if there's anything on this review, I know we didn't get too much on this review, but if there's anything on this review, this is the one that's coming up Thursday, right? So you can also come ask me questions during office hours. All right. I'm going to stop recording.